Hello everyone. So let's now solve practice assignment week 7 question number 1. Let V1 equal to R3 be a vector space. Define a function from V1 to R for I equal to 0, 1, 2, 3. So we have four functions defined here. And V2 is a vector space for matrix 2 cross 2. And we are defining a function from V2 to R as follows. Now which of the following options are true? So options are asking us to check that which of these six functions satisfy the norm criteria. The criteria for any function to be norm is the norm of x, or the function by which we are defining it, should be greater than 0, and norm of x is equal to 0 if and only if x is 0. So this is the first condition. Second condition is norm of c times of x is mod of c times norm of x. And the third condition would be the triangular inequality, that is the sum of the two would be less than or equal to the individual sum. So if any function satisfies these criteria, that would be considered as the norm. So we will be checking these three conditions on each of the option. So let's start with norm 0, the function 0 here. So our function is defined as like this. That is, for any vector in R3, this function is x plus y plus z. So if we try checking the first condition on this function, then let's take an example for finding the norm of 1 minus 1, 0. Then based on this condition, that is the summing of all the elements, so it would be 1 minus 1 plus 0, that is equal to 0. So we are getting 0 while our vector for which you are trying to find is not equal to 0. So this condition fails, as the first condition of the norm for any function to be classified as norm, it should satisfy the criteria that it should only be 0 when our vector is 0. But here we are getting 0 without our vector to be 0, so this function will not classify as the norm. So first option is wrong, that the function 0 is a norm on V1. Now let's try with the second. So this is defined as the sum of absolute values of the elements. Now let's try checking. So first of all, the first condition, that is, this should be the norm for a function to be greater than 0 and will only be 0 when our vector itself is 0. So as we are taking the sum of the absolute values, so that means this quantity can never be less than 0. And as all these values would be positive, so summing up of three positive values can only be turned out to be 0 when each of them, that is mod of x, mod of y, mod of z, corresponds to the 0. And that means that means we will get 0 only if our vector itself is 0. So the expression would always be greater than 0 and will only be equal to 0 if mod of x equal to mod of y equal to mod of z is equal to 0, and that implies that x, y, z would be a 0 vector. So the first condition is satisfied. Now let's try checking for the second condition. So the second condition is this. So if we try checking it, then it would be, and we can write the above expression as mod of c times mod of x. plus mod of c times mod of y plus mod of c times mod of z. We can take the mod of c common here and we will get mod of x plus mod of y plus mod of z. And here this is nothing but the norm 1. So it would be so our second condition is also satisfied. Now we have to check the third condition, that is a triangle inequality on this. So we can take two vectors x1 comma y1 comma z1 plus x2 comma y2 comma z2, and if we go with the definition of the function, then we will get mod of x1 plus x2 plus mod of y1 plus y2 and plus mod of z1 plus z2. And we know that this quantity would always be less than or equal to the individual sum of the elements, that is mod of x1 plus mod of x2 plus mod of y1 plus mod of y2 plus mod of z1 plus mod of z2. Now the reason is we can like kind of go with the intuition also that here we are summing these two quantities, and here the what might happen that this quantity might be less this quantity, like there can be the scenarios where x2 can be negative or x1 can be negative. So overall this value, that is the sum of two elements and then we take the absolute value, would be less than if we first find the absolute value of these two elements and then sum it. For example, like if we have x1 value to be 3 and x2 to be value minus 5, if we are going to sum these up, we will get minus 2 and then take the absolute value, we will get 2. While if we first take the absolute value, that is mod of 3 and then 5, then we will get 3 plus 5, that is 8. So this sum would always be less than equal to the sum of the individual elements. And if we rearrange these terms, plus mod of y1 plus mod of z1 plus mod of x2 plus mod of y2 plus mod of z2. So this here corresponds to our x1, y1, z1. While the second quantity refers to the function value with respect to the x2, y2, z2. So we have proved the last condition of the norm, that is a triangular inequality. So as this function satisfies all the three quantity, so it is classified as norm. While the option is given as it is not a norm, so it is wrong option. Now let's check for the third. And the third is nothing but our usual norm, that if we see it is the square root of x square plus y square plus z square, and our usual norm is defined as the square root of the dot product. So the dot product with x comma y comma z with itself would corresponds to x square plus y square plus z square, and the square root of it, that is our usual norm. So our usual or general norm is defined as the square root of usual dot product. So this is the general definition of our dot products for norm. So that's why this is also a norm. So third option is correct. Now fourth, that function 3 is not a norm on V1. So function 3 is defined as maximum of absolute values. So now this is function 3. Now again, first we will try with the first condition, that is this quantity should always be greater than 0 and will only be 0 when our vector itself is 0. So again, by going with the same logic that we did before, as these are all the absolute values, so this quantity will always be greater than 0. And as we are taking the maximum of it, so that means we will get 0 only when all of them are 0. As the overall, this quantity will always be greater than 0, so I will never get a negative value that is less than 0. So this will only correspond to 0 when all these x, y, z values are 0. So our first condition is satisfied. And for the second condition, that is c times x comma y comma z. So again, we can take the modulus of c common and we will left with this. So we got the same part that is here. So the second condition is also satisfied. Now let's take the last condition, that is triangle inequality. X1 comma y1 comma z1 plus x2 comma y2 comma z2. So this would be maximum of so again the same logic that we discussed, that this would be less than or equal to mod of x1 comma mod of y1 plus maximum of so as it satisfies the triangle inequality and all the other two conditions is also satisfied. So this function is a norm, but in the option it is given that it is not a norm, so the option is incorrect. Now we will checking the function criteria on the last two. So our fourth function is now it is defined on a matrix. So here our V2, which is of matrix of order 2 cross 2, and we have A, which belongs to V2. So our fourth function is defined as maximum of where A is of matrix A11, A12, A21, and A22. So this is our matrix, and that's how we are defining our function. So if we checking for the value of, we'll try checking the first property. So that is, this should be greater than or equal to 0, and this should only be 0 when all our matrix would be a 0 matrix. So again, all of these are like positive value, or we can say absolute values. So this quantity will always be greater than 0. And as we are summing the some positive quantity, so this would only be 0 when all these values are 0. That is, this value is 0 and this value is 0. And add this the sum of two positive quantity. So that means for it to be 0, A11 should be 0 and A12 should be 0. And for this to be 0, so we will get our whole A matrix to be the 0 matrix. Only then this can be 0. So the first condition is satisfied. Now let's check for the second one. Now again we can take the mode of C common and write the expression as above. So our second condition is also satisfied. Now the last condition, that is triangle inequality. So we'll consider two matrices. Our first matrix is the same A matrix, and second matrix is B matrix. So our A plus B, A11 plus B11, A12 plus B12, A21 plus B21, A22 plus B22. Now if we try finding the function value on this, so maximum of A11 plus B11 plus A12 plus B12, A21 plus B21 plus A22 plus B22. Now this is we have already seen while we were trying to prove this, that the maximum of this would be less than equal to the maximum of individual. So again, by going with that same logic, I can write it as this would be less than equal to maximum of plus maximum of so the triangle inequality is satisfied for this, and other two is also satisfied for this function classified as norm. But option says it is not a norm, so this option is incorrect. Now for the fifth, if we look at the fifth and the fourth, there's nothing much that much difference if we say as or anything if it is changed, that is here it is A12, here it is A21, and here it is A21 and A12. Basically, these two are changed, and that's all. So it's not going to affect that much if we see overall. So if we try, it is technically the same as the fourth one. So this will also considered as the norm. So that's why fifth option is also correct. Thank you.